Thank you, Adrian. We're thrilled to be here, and I'm actually in Dutchess County. Phil Davis, my colleague, is in Harlem, and Colin is in the Catskills. So here we are, and I actually don't have a very large part in this because I'm the pen and ink person. I'm an architect who learned how to draw using a Mayline with a lead clutch and graphite, and then graduated to the most annoying kind of pen you can imagine called a rapidograph, which is basically a clutch with a needle in it on where we would draw on Mylar, which is like a polyester film. I also learned how to draw with a pen and ink with a detachable nib on vellum. And so my background is actually in the Stone Ages compared to what my colleagues are doing. There are others in my firm who design using a pencil every day. There are 3 or 4 total, but the rest of the firm is purely on screens. And we've made a point as a traditionally based firm of being early adopters of technology. And it's a little challenging for me because I don't understand it all. I actually don't know how to operate some of the systems, but I think it's incredibly important for us as traditionally inspired architects to embrace the tools that allow us to do better work and serve our clients better. Another aspect of it that's very exciting and is emerging in our work is that the kind of data these models create can go directly to the makers of things in our buildings. We can send a digital file to a company that has CNC machinery that fashions hardware. We can send digital data to a company that has computer-driven machinery that will make components of a stair. So it's actually freeing us to do things that are incredibly challenging and sort of breaking down the barrier between the designer and the maker of things and the maker of parts of our buildings. I do want to say that for any of you who have expect to see glorious classical architecture, Corinthian capitals, and temples, and Adam villas. We have actually chosen, or Phil and Colin have chosen the examples today, not so much for the architectural attributes as for their specificity in demonstrating how the software works. So you may see a kitchen or two, and we're proud of our kitchens, and whatever those projects are best show our capacity. We'll go through some of these slides. These are examples of our drawings. These happen to be done by a wonderful architect named Anton Gleichen. And we go on to the next one. So here is an example of a drawing that I still feel probably couldn't be done as well in the virtual world. Phil and Colin may disagree with me, but this is a mantelpiece in a new house that we designed recently. An example of a section through a townhouse, which is a hand drawing, which is then mounted and formatted, so it becomes part of a digital presentation, but it's a hand drawing, and it's a huge drawing. It's 42 inches tall, and it has great detail. Just terrific detail with pen and ink. It's unparalleled. And finally, this is an example of a drawing of a dome, a cast iron domed lay light, which sits under a skylight in a very substantial Beaux-Arts style house on 79th Street. And in this case, you can see that the architect was able to draw 2 quadrants of it. With the digital tools we have now, this would have worked much better. We could have completed it. We could have made it express its dimensionality better. So I want to thank Colin and Phil, who are wonderful team members of our office. And also I want to say, and you'll see a slide at the end, that all of these projects involve many other people in our firm, and we added a slide that lists them all. Take it away.
Okay, so at PPA, we have 2 primary workflows. One is based in CAD and the other in BIM. We decide which one to use for each project depending on that project's specific needs and which team members are available to work on that project at the time. If we're working in CAD, the project teams will develop a full set of 2-dimensional drawings which serve as the foundational documents for that project. Any 3D models or other supplementary materials that are needed for the project are developed in parallel using those 2D drawings as a reference. If the design changes at any point after those 3D models are already underway, those changes have to be manually coordinated between the 2D and 3D teams. And likewise, any changes that are made directly to the 3D models while it's under review have to be communicated back to the CAD team. Typically, once a project receives final design approval from the client, it proceeds in 2D only from that point forward. So here we have an early design sketch of an apartment in New York City. The area indicated within this rectangle is the main entry sequence for the apartment, and this includes a gallery space and a large spiral stair at the end of the axis. This gallery area was of particular importance to the project as the client had a significant art collection and was thinking about putting some of their most important pieces in this space. The art selection here had the potential to really meaningfully impact the design, as different pieces want to be shown against different materials, and some of the pieces had structural or size and clearance requirements in order to be moved or displayed properly. So because of that, we identified this space as a good candidate for digital rendering. That would allow us to create presentation materials that included the art and could be understood immediately, which would help the client explore options and make informed decisions. So working from the designer's sketches, the project team produced a set of 2D CAD drawings like this interior elevation. These drawings served as the primary documentation of the project. They were used to create presentation drawings, construction documents, and they were also handed over to the 3D modeling team and used to create a 3D digital model of the space. This model was built in a program called SketchUp, which we like for its speed and its flexibility. You can see here that SketchUp also allows us to capture quite a bit of detail. For instance, in this space, each piece of the stone in the floor is modeled individually. Modeling at this level of detail ensures that the entirety of our design can be faithfully captured in our renderings, and that allows us to convey as much information as we feel is necessary at any point in the project. However, you will notice that the stair at the end of the axis is missing entirely, and that's because it was built in a separate piece of software called Rhino 3D. Rhino is much better at dealing with geometry that has complex curvature, so the repeating pattern in a handrail that follows an elliptical spiral stair was a much better fit for Rhino's strengths than SketchUp. We then move into a piece of software called 3D Studio Max, where we bring together and merge the geometry coming from SketchUp and Rhino. We then introduce lighting information and apply textures and materials to the surfaces of the model. And crucially, this is also where we start to incorporate the art into the space. And using this software, we're able to produce digital renderings like this one that we present to the client. And these images help the client decide which pieces of art to display where and choose the materials that will help the art look its best. And those are the kinds of decisions that, if you leave them unmade, they have the potential to really introduce a lot of delay into a project. And that's especially true if the client makes a decision, but then loses confidence later on in the project and wants to go back and make changes to things. But as you can see from this photograph of the finished apartment, the client was pretty happy with what they saw, and we were able to move forward based on the renderings that they approved with confidence.
And those aren't family pets. That's La Lawn sheep, actually.
Thanks, Phil. The second and most recent workflow adopted by PPA is the BIM workflow. You could teach an entire semester on BIM and how to use the various BIM tools, so I'm simply going to give a few bullet points for those who aren't familiar. BIM stands for Building Information Modeling. One of the most widely adopted software for BIM is Autodesk Revit, which is often referred to interchangeably with BIM. Instead of creating 2D line drawings like you would with CAD, with BIM, you are building a 3D model of the building as if you were constructing it in real life. This 3D model serves as the basis for all of your documentation. Drawings like floor plans and elevations become views of a single model. This means that as changes are made, all of the drawings or views are automatically updated simultaneously. In the background, a BIM model is essentially a visualized database. All the elements within the model carry information, and this information can be organized into schedules that are also automatically updated as the project progresses and can even be used to manipulate the geometry. Because one file is the source of all the information, Revit has the capability for multiple team members to be working on the same model at the same time. In some cases, these teams can get quite large. Additionally, BIM also provides the added benefit of being able to coordinate three-dimensionally with consultants and run various analyses like lighting or energy, among many other things. Here you can see on the left, we are demonstrating a successful route for a chimney flue from the fireplace to the chimney through structural, mechanical, and architectural obstacles. And on the right is a live coordination view of a reflected ceiling plan. We use these as a quick visual check to see if ductwork is poking through the ceiling. The bright green ducts you see here clue us into areas that require more attention. Recently, we've introduced an additional program called Revisto, which allows for project team members as well as non-Revit users to see the latest and greatest drawings and models auto-updated daily from the live Revit model. This allows for easy review of architectural as well as consultant models and has a robust issue tracking system for communicating and task listing. The 2D drawings can be overlaid on the 3D model for quick contextual reference. So why BIM? Among all the reasons that I previously mentioned, one of the more interesting and important ones to PPA is the convergence of 2D and 3D efforts that you saw in the CAD workflow. Because the BIM model is the source for all the drawings and the 3D information, when we go to render for a client presentation, all we need to do is export the model. There may be some cleanup, but that work usually turns out to be necessary regardless. Where previously two teams had to keep things coordinated and up to date between the CAD drawings and a separate 3D model, now all of this happens automatically, significantly reducing redundancy. You can see in the diagram how the BIM model starts at concept and carries on through the life of the project, while other ancillary efforts like client presentation and construction documentation alike branch off of it. A lot of what PPA does is related to renovation projects. So as an example of BIM, I'm going to start with the very beginning with a survey model. In recent years, we have been hiring surveyors to provide point cloud scans and then create Revit models of the existing conditions for us.
So Colin, could I just ask, so just to be clear, this is an image made of dots, which are all the data points. It almost looks like a photograph, but it's a collection of data points from the laser. Is that right?
Correct, and it's a three-dimensional image. So the scanner basically scans the entire room and reports back points when it hits solid surfaces. And that's where you get point cloud from. It's just a bunch of points. And it takes multiple scans in different rooms in order to achieve a full picture of the space. And the surveyor will create a Revit model based on that point cloud information as part of their deliverable. And beyond that, we can actually overlay this point cloud onto our architectural Revit model to verify things against the existing conditions. In the case of this scan, we were under time constraints to get the survey model started, and the previous tenant hadn't moved out yet. As you can see, the scan captures everything. Ideally, we would start with an empty apartment, but the surveyor was able to construct the model from it. You can see the blue highlighted object there is a window that's part of the actual Revit model. In the case of an existing apartment renovation, the team will then take the model provided by the surveyor and begin virtually demolishing the interiors based on the design. Because Revit allows for phasing of projects, we can document the demolition directly in the model. The team is then able to use the surveyor's model and the point cloud to verify important dimensions and feed that information to the designer. Seen here, PPA designer Ryan Hughes created hand drawings of what will eventually be the new library. Though it's still an ongoing effort at PPA, we are continually trying to find ways to streamline the process of integrating the basic details of a typical classical room into our Revit workflow. We begin with generic models of things like casings, mantles, and window jambs, and try to set up a workflow that allows team members to easily customize these elements to the individual project. This gets us about 85% of the way there, with an additional 15% being set aside for specialty modeling to capture less typical conditions. In the video, you can see the team has begun using these elements to create a model based on the hand sketches seen in the previous slide. The library is now a fully worked out 3D space. Once basic modeling is complete, the team can begin to focus not only on the 3D work, but the 2D drawings that will be used for documentation. This floor plan was derived directly from the model that you saw previously. In this case, the team was focused on furniture and floor plan layout for a presentation image for the client. And from the same model, the interior elevations. Annotation and dimension will be eventually added to these to create the elevations that will be used for the construction documents. And it's also worth noting that this particular project is on the boards and is about to go into the construction document phase. Lastly, a perspective line drawing derived from the same model for the use of a client presentation. In some cases, we choose not to render at all. Instead, we use line drawings like this that are views with a live Revit model. Because all these drawings are simply views of the same model, as detail is added to the model or changes are made to the design, these are all updated automatically. This allows the team to make changes for an upcoming presentation or deadline rapidly. We sometimes take these early renderings a step further and use white box render method to demonstrate the feel of the design geometry without getting into the weeds with making definitive material decisions. Lumion is the tool of choice for this, as it can rapidly create quality renders with a very small time commitment and no need for post-processing. On another project, starting from one of Gregory Gilmartin's hand sketches of an Art Deco corner detail, the project team is given a series of sketch vignettes to measure and develop in Revit. In this case, because this detail repeats in various forms throughout the building, we decided to make this a family that can be placed in multiple locations. A family in Revit is roughly equivalent to a CAD block. The design consists of a corner pedestal with a series of dripping edge chamfers. On top of the pedestal sits an ornament. In order to make this flexible enough to use in multiple locations, parameters were added that allowed team members to essentially pull the chamfer down the side of the building to different levels depending on where it is located.
And Colin, will this allow the stone production people to mill for using this as a background? How do they integrate that?
This would be, they would go off of the construction documents, kind of the traditional way. However, if we have the full capability of providing them the model in order to do that. I think in this case it didn't happen, but it is absolutely possible.
And just one more note to give people a sense of the scale, the lantern you're looking at there is 78 inches tall.
That's true. And another thing that we built into this family is the ability to swap out the details. That you have the urn on the left and the lantern on the right just by basically selecting them out of a list. And these two images were just taken directly off of the Revit model. And then again, same model was used to create this documentation page, which is what we were talking about a minute ago. This would go to the fabricator in this case. We also have begun to use Revit to help us organize large estate projects that consist of multiple buildings. This allows us to study different layouts, do sun studies, and organize models. Even if they aren't all native Revit models, they can all be brought into the site and studied together, even if it was coming from SketchUp or another tool. This is a horse farm in Kentucky that is currently on the boards. We can then export the entire site into Lumion. We've been developing this hand sketch effect application in Lumion to render exterior projects. Lumion does a really great job of creating realistic looking artistic effects that do not need to be post-processed. It also has a very robust library of plants and trees for convincing exterior renders, which is why it is also widely used by landscape architects. This is the horse farm model that you saw on the previous slide with some added Lumion foliage for added effect. Because Lumion allows for rapid rendering, we will sometime use it to create quick option studies to aid in client decision making. Here, the client had requested as many bookshelves as possible in this room and specifically asked for built-ins under the windows. We felt like this blocked too much natural light and created a cave-like atmosphere. So we showed him this alternate without the built-ins. In the end, he agreed that the natural light was more important. These images were created by simply loading the live Revit model into the Lumion render program and rendering the two versions with accurate daylighting. Once the design and modeling work has been completed, this whole process of creating these renders didn't take more than 20 minutes.
So those techniques are sufficient for most situations, but we occasionally find ourselves in need of something a little more specialized. For instance, 3D printing. We have a 3D printer located in our office. You can see it here being operated by a devilishly handsome young man in sort of an ill-fitting shirt. This machine uses what's called a polyjet technology that allows for a much finer surface finish than most other 3D printers can achieve. It also has a very large build envelope, which allows us to print pieces up to 17 inches across in one go. Since we've started 3D printing, we found that most of our models fall into one of three categories. First, there are the small massing models. These are typically produced at 16th inch scale and are edited down to contain very little information beyond massing. As you can see, the openings here are indicated by changes in plane, but nothing beyond that level of detail is communicated. The small size and simplicity of these models makes them very quick to produce and also very easy to iterate on. Building the first version of the model takes time, but subsequent changes can be captured in 3D quickly and a new model printed. That ease of iteration is one of the main benefits of 3D printing, because the work that you did to produce your previous model isn't lost when you start working on your next one. For some projects, we've been able to produce and present models like this one on a weekly basis. And just to be clear, that's the limit of the client's schedule, not the machine or our workflow. We could have gone faster than that if we needed to. We also use the 3D printer to produce prototypes of custom hardware if we're producing any for the project. Here you can see a few options for lever handles. This hardware design process also begins in 2D. Here you can see some CAD drawings describing a custom knob from one of our designers. That 2D CAD was then brought into Rhino, which is our preferred tool for this sort of thing. On the left, you can see the profile that was handed off by the designer, but a key change has been introduced. Here inside this rectangle, some of these little lines have been added that actually introduce a 1/100th of an inch gap between the knob itself and the rosette surrounding the knob. These profiles are then used to create a digital 3D model that you see on the right. And then those 3D models are sent to the printer and they're printed together as one print. After the cleaning process, that small gap that we introduced between the knob and the rosette allows the knob to turn freely if you hold the rosette in your hand. And as simple as it may sound, the ability to turn the knob in your hand when you're holding it really helps you evaluate the design. Here's the printed model, which here you can see we've coated with a metallic finish. But in fact, this model, it wasn't just painted, because while reviewing earlier versions of this knob, the client said they had a hard time evaluating it since it was made from the lightweight plastic that the 3D printer uses, and the ultimate model, the ultimate knob would be made out of metal. So to remedy that, we actually printed this version of the knob hollow and then filled it with powdered tungsten to make it heavier so that it would better approximate the heft of a solid brass knob. And I think that's a great example of the kind of flexibility that 3D printing gives us to find creative solutions to problems. And here's the prototype that the hardware fabricator produced. And this was only made after both we and the client were both satisfied with our internal prototype. If we had gone straight from the CAD drawings to the fabricator, this process would have taken much longer, and it also would have been much more expensive. That's another one of the major benefits of 3D printing, is that it lets us do our iterating in a fast and less expensive medium. We also produce large, highly detailed models for display. Here's a model of a house in Long Island that's on display in our office currently, and you can see from the penny that this is a quite large model. It had to be printed in multiple pieces and then assembled afterwards to achieve this size. And if you look closer, you can see it's also very information dense. There's a brick texture on the wall, the shutters have texture, all the molding profiles are included, even the downspouts are indicated here. It really tells you a lot about the design of this home. This model that you might recognize of a Czech cubist house in Ohio falls into this display model category. So let's talk briefly about how a model like this might be made. SketchUp, we found, is extremely well suited for 3D printing work. This is the SketchUp model that we used to produce the model that you just saw. The most important thing to note here is that this SketchUp model is purpose-built for 3D printing. We made other 3D models for other purposes for this model, but we can't just use them interchangeably. And that's because we had to introduce some key changes for the benefit of a 3D printed physical model. If you take a closer look at this facade, specifically in the areas indicated here, there are some coplanar changes in material in this facade. And since we prefer a monochrome white finish in our display models, we had to indicate this material change in some other way. In this instance, we've done so by introducing grooves that run across the facade, and they had to be drawn 2 inches wide in order to read well at the size of the final model. Obviously, these 2-inch grooves aren't present in the actual design of the real house, but they're necessary here to communicate the actual design intent. Here you can see those exaggerated details make the model legible at a distance. You can tell there's some articulation in the design at the tops of the chimneys as well as at the base of the house, even though it's all the same color. Incidentally, the client liked this model so much they requested an additional copy for them to have for themselves, which is yet another benefit of 3D printing, because once the model is printed, making an additional copy is basically as simple as hitting the print button again. And here's just a shot of the actual house for comparison.
We also use digital tools to help inform the designers for specific exercises. During the design of the Czech Cubist house that we were just looking at, the main entry was focused on for this. The project team wanted to interpret a linear vertical color gradient over a 3D faceted volume into a 2D unfolded series of polygons, which is a mouthful. A base model of the space was built in Rhino, then unfolded. You can see in the slide 3D and unfolded 2D representation of the space. Grasshopper, a visual scripting plugin for Rhino, was used to apply the gradient to the shapes. In the window in the bottom right quadrant, you can see the multiple gradient options in the sliders and the scripts that create the gradients on the shapes. The flattened gradient pieces were then printed and given to the designer, Anton Glicken.
I also just want to point out that this room was inspired by a great banking hall in the building 1 Wall Street, which is Ralph Walker's great Art Deco skyscraper. And that banking hall was a work by the artist mosaicist Hildreth Mayer. And so if some of you know New York architecture well, you'll recognize the style of this room, but applying it in a space this small was very challenging.
Thanks, Peter. And after the grasshopper script had been applied to those flat pieces, it was then given to the designer, who applied an artistic silver web pattern to it. You can see all the paper models and hand-painted web patterns applied here. And then it was taken back into the digital world in AutoCAD and put into the construction documents. And so you can see here, the mosaic artisan that applied this in the final room used this as a spring point to start their design. You can see the final room here. We think that bouncing back and forth between the digital and analog is where you can really get some really fantastic, intriguing moments.
So if we can return to the topic of digital renderings here, we find renderings like this one are very useful tools, but they definitely do have some drawbacks. Namely, they don't leave very much to the imagination. They present small or incidental design details with as much fidelity as the core architectural ideas of the space. For instance, you might present this image intending to discuss the organizing logic of the kitchen storage, but end up spending the bulk of your time talking about how these particular stools are not to the client's taste. We found some success in sidestepping this issue by producing images more like this one. This is the same digital rendering you just saw, but it's been post-processed to more closely resemble a hand-done watercolor rendering. It contains all the same information as the photoreal rendering, but it has a much looser and sketchier feel. We found that this really helps to convey a sense that decisions are still being made here, and that the thing that we're presenting to the client is an idea about the kitchen. We're not dictating to them which stools they must sit in while they eat breakfast. So let's talk briefly about how an image like this is produced. It starts with a standard digital rendering. We then use a plugin to 3ds Max that's focused on producing line work to create a line rendering of the architecture that exactly matches the rendered view that we've produced. We produce another line drawing that captures the furnishings in the space. Alongside the primary image that our renderer produces, it can also produce these specialized images that contain technical information. Here, each pixel of the image is colored either black or white, depending on whether it's part of the architecture or the furnishings. We typically produce a number of these informational images alongside the main rendering, and you can see a few more examples here. These contain information about direct versus indirect lighting, or orientation relative to the camera or relative to 3D space, or which materials are applied to which object. These sorts of informational images are immensely helpful in post-processing as they give you pixel by pixel access to the underlying information that drives the rendering. So we gather all of these materials, we bring them into Photoshop, and we start working on the color information of the image until we arrive at something like this that has a more painterly quality. We add a texture that better mimics the interaction of watercolor paint and the paper to which it's applied. We introduce the rendered line work, and then with a few overall color adjustments, we have the final image. Now, there is a lot going on under the hood here in Photoshop. This is a pretty complex process, but it's very repeatable, and it only takes a little more than 10 minutes to go from the raw rendered output to this image. And obviously this isn't a perfect substitute for an actual hand-rendered watercolor rendering, but in situations where we're already producing digital renderings, we found these are pretty quick to produce and they can be very useful in client presentations. We've also been making good use of virtual reality headsets, one of which you can see here. Most of our headset-based presentations to this point have taken the form of a stereoscopic panorama. And what that means is you're taking a panoramic image like this one, which captures a full 360-degree view from a single point in space and produces one of these for each eye. The headset then presents each of the viewer's eyes with its corresponding panoramic image, allowing them to look around the space and experience it with a sense of depth that's really comparable to viewing it in real life. This is a really powerful technology. The sense of space you get from it, I think, is really real. I really believe this is the most powerful new technology for presenting architectural ideas that's emerged since I've started working in the field. Panoramas like this are driven by images that look like this. And I know this looks strange or complicated, but it's really just a JPEG image. It doesn't rely on some exotic process or file type. In fact, if you're already producing digital renderings, the odds are very good that the software you're using can produce an image like this one with very little additional work. In our software, for instance, the difference between a standard digital rendering and a 3D stereoscopic rendering is just 2 mouse clicks.
Looking forward, recently we have begun finding ways to utilize virtual reality as a way for design review and coordination, as well as client presentation. PPA has attempted this in the past, where it would take a specially built model to render overnight and then viewed in a clunky VR software. The technology has advanced in recent years, so much so that we can take an as-is Revit model and be walking through it in a matter of minutes. We've been using Prospect VR as a tool for this, which is focused on meetings within VR projects with multiple people. In this slide, we are reviewing modeling issues as well as mechanical conflicts. The mechanical engineer has also joined us from their office a few blocks away and is walking through the project with us. Last week, my colleague and I reviewed this stair hall. Both of us were in our living rooms. The dollhouse view you see here in the beginning allows us to view the model as if it was a physical scale model, not unlike one of Phil's 3D prints. We can then jump in for a more detailed discussion. We can make markups. We can take photos of those markups, and then those photos actually become meeting minutes for an auto-generated list of tasks after the meeting has taken place. The markups can be drawn on walls, ceilings, projected onto surfaces. As you can see here, marking out a place for a chandelier, and then also you can draw 3-dimensionally, also seen here being done very badly by myself. A little bit more practice and we'll get the hang of it. At the beginning of the year, we hosted our first client walkthrough in VR. The client was very happy with the design and provided a lot of great feedback to the team while he inspected his future home. Another use for this technology is the ability for designers who may not have full access to 3D tools to stand in their design and review it with the team. We've just begun exploring the possibilities of VR meetings and hope to take full advantage of it in the future.
Thank you very much. That was really interesting. And I know it's a lot to think about, and it got very technical at points. And I think it may inspire us to branch out and do more of this and dive deeper into some of these subjects. And we're very grateful to the ICAA for hosting us.
Yeah, I see a question here. Do you favor VR usage during the beginning of design, near the end of client approval, or do you use it for both? In my experience, we've used it sort of throughout the life of a project. It's really helpful early on. It's really good at driving client approval if the client is well suited to working in VR. We've also used it sometimes later in the project if there's some sort of spot fix that we need for a project that's like almost under construction. They want to make a change, but they want to see what that change is going to look like in the finished product. We can do it really whenever we need to.
Yeah, and I've had the experience of, we had a client that just really didn't understand the scale of some architectural columns in her living room. So we actually created one of those 3D stereoscopics standing next to the column so that she could stand there and inspect it next to it. And that helped her make the decision to move forward with that design.
I think it also opens our eyes up to issues in our designs. You know, it's not just, I mean, it's clearly useful for the clients, but it also is extraordinary to be able to stand in a space and have a 360-degree view.
Yes, that's absolutely true. All the benefits that apply to clients apply to designers as well.
Yeah.
Yeah.
There's a question here about assembling 3D printed pieces for larger scaled models, which can be challenging due to warping and shrinkage. And they're asking about our process to reach high quality finished assembled projects. I guess the trick there is to assemble it quickly. It also helps that I now have been working with this specific variety of 3D printer for 12 years. I have some experience with the technology. So I've discovered a few tricks to help reinforce the model and prevent them from warping. But the real secret, I think, is just to carefully select where your joints happen and make sure that they're well reinforced and get the most unstable joints assembled as quickly as possible.
I think it's almost the way we treat expansion joints when we do a building. You know, we've done high-rise on masonry facades. It's a little bit like that. You have to choose where those joints happen, and they coincide with planes, changes in plane and the architecture.
Right. There's a question here about whether we've encountered issues with VR akin to the renderings that are too perfect or detailed so that clients take issue with details. I'm not sure if that's happened specifically, but it's certainly something that we're considering. The watercolor rendering process that I described doesn't work well for VR. It introduces a little bit of jitter or randomness to the image, which if you view it stereoscopically would not work well. Like the images that your two eyes receives wouldn't match. So we're still looking for a solution there.
I've had issues. I've seen where the details and materials have thrown the conversation off. So earlier in the presentation, I showed a static image of a white box render, and we've used that sort of technique in the past to just kind of wipe out the materiality so that doesn't distract from the conversation.
We've also, for example, on one project, had all the furniture in the views of a living room, library, dining room opening to one another in the same blue fabric, which was just a solid, and then the client understands, and you can sort of make your brain see that anything blue is a placeholder, as opposed to having more specific interior decoration schemes.
Yes. And speaking of that, there's a question here about where we get our furniture models. There are a few sites that we like. We buy most of them online. If we have something really special or specific that the client needs, we can model them in-house. But it's really much faster just to purchase anything we can. Probably the site we use most has the incredible professional and fun to say name called, it's turbosquid.com. It has a pretty broad selection, so we find most of our stuff there.
Is that where we find our books too? We occasionally have to buy books for
Yes.
library.
Yeah, we've gotten many book models there as well. A question here, how precise are these survey models that we receive? Colin, if you want to speak to that.
Yeah, well, the point clouds themselves are obviously exactly precise because it's essentially a 3D photo of the actual space. It depends on the quality of the modeling from the surveyor. I've been fairly happy with what we've gotten back. We work with a couple of different people. Originally, we did a lot of work with existing conditions, and now we've been using BIM Scouts, and they've done a really great job of
It's especially helpful when we're dealing with an historic building where no wall is flat and everything's out of plumb. So we did a complete restoration of the oldest extant house in Suffolk County. It was built in the middle 1600s or 1660s. And literally no plane was square, nothing was plumb, and there would not have been a way of measuring that using conventional tapes and lasers. So in that case, the scan was invaluable.
Yeah.
There's a question here. Are there any systems that update the VR model as you update within Revit or CAD? I don't know, Colin, if you can speak to that with your VR meeting software.
Let's see, where's that one?
Oh, now it's vanished. But the question was, are there any programs that can update the VR model live while you work in Revit or CAD?
It doesn't do it live. The one that we use doesn't do it live, and we tried a number of different ones. But the process of uploading a change into the program, into the headset, is really fast. It obviously takes longer the bigger the project is. In our case, if it's like an apartment renovation, it can go pretty quickly. A large, university building or something like that would take a much longer time to do. But it's fairly fast to get changes made from Revit and then into the software.
The next question here, is Lumion compatible with SketchUp? Yes, very. One of the reasons we like Lumion is that it is compatible with many of the rendering or modeling softwares that we use, but I'd say it's particularly compatible with SketchUp.
Yeah, a lot of our renderings that we do are actually sometimes a combination of Revit and SketchUp because parts of the building had been done previously or for whatever reason, but it blends it very well.
Yes. And then the next question, can you use SketchUp for VR with headsets? Yes, but you're going to need to work with some rendering software as an intermediary. SketchUp can't produce the right kind of image, and it also doesn't have the right kind of presentation quality that you'd want without going through a renderer. But the 3ds Max, the rendering software that we use, accepts SketchUp geometry readily, and it produces the kind of images that you need for the headset. So SketchUp is a great place to start. Sorry, go ahead.
Sorry, but if you're talking about VR meetings, that is actually very doable. You can load a SketchUp model into the VR headset, similar to Revit. It's just the reason it makes more sense to do in Revit because you have the complete model. But we have done that as well with SketchUp.
How do you manage the design process when clients are able to participate so much more? How can the design be concluded for the CD phase to begin?
I mean, I think that's always a question, and it was a question before any of these digital tools. What we always organize on our schedule is how many design meetings there are and what parts of the building we're covering in those design meetings. Clients rarely follow the script exactly, nor should they feel they have to, but it gives the clients a sense of the structure of the design process. Without that, one could simply skip from design meeting to design meeting and not without any forward momentum. And I think it's a universal problem. And normally having a good plan and listening and setting out a program very carefully gets us to move forward. Having said that, we also will dive deep into certain details. We will commission full-scale mock-ups often, certainly of parts of the building, but often, of sections of a wall, with a window, with a cornice, and certainly all the moldings and paneling and all those elements must be presented, in a full-scale mock-up, and that definitely helps.
Is there a realistic rendering add-on that you would recommend using with SketchUp? Well, if you want to work directly within SketchUp, I think the most popular choice there is V-Ray. The rendering plugin for 3ds Max that we use is called Corona. We prefer it because it has some quality of life improvements over V-Ray, but V-Ray produces, it's the industry standard. It produces very good results. And again, a lot of our highly detailed rendering geometry starts in SketchUp. We just move to 3ds Max and then render it there. But if you want to work directly in SketchUp, probably V-Ray is your best choice. And now a question. How much productivity would you estimate to have gained from schematics to CDs by using BIM?
That's a good question. The office has kind of gone through a process where basically you can do it one of two ways. You can either say we're going to only do Revit from here on out, and it's like ripping a Band-Aid off, and it's very hard and tough going at the very beginning, but everyone catches up really fast. The way PPA has done it is kind of in a phased way. So some of the teams at this point, I think, are working very efficiently. Other teams are still in the beginning phase, and they're going through those kind of growing pains. So it's kind of hard to quantify that completely. I was thinking about this earlier, and one thing that I can say that's different between BIM and the CAD workflow is that you will have to put more effort up front in order to get that model up and running and information, in there. But once that's there, everything starts to spill out a lot faster. So there's more effort up front, and you kind of have to front load your projects a little bit more than you would with a typical CAD project.
And it's definitely much more efficient when you change a window or something and it automatically changes the schedules and all the specs. I mean, that's just incredibly efficient. But overall, moving into BIM as a firm of our size with our kind of commission has been an expensive, undertaking. It's been an investment in time, and it's been costly, but it's paying dividends.
And then a question, just how large is your BIM family library at this point?
That's also an interesting question, because we're kind of halfway through developing a full-on library, and the reason for that is the way PPA designs and the types of items that we have in the library are kind of being created as the projects progress. So now that we have, I would say 3 or 4 projects behind us, we have a pretty nice system of doors and windows. We have a full furniture library, but we're still in process of collecting those typical things that we would use between all of our projects and making them either part of a template or part of just the library. So I don't have a number for you, but it's a growing, kind of evolving system.
Another BIM question. When did PPA start using BIM? And can you describe how that initial integration and evolution to the current mature workflow unfolded?
So I started 2 years ago in November, I believe. At that point, there was one house project underway and a tower project that I was just getting started. I believe that all had begun about a year prior, if I'm right, Peter.
We chose with our condominium tower to not only be the design architect, but the architect of record. So this really brought us into the BIM world.
Right. So I would say 2 years ago when I started, I and I was brought in as the BIM director to kind of help organize and get the workflows and everything under control. So there was some growing pains at the beginning, and then I believe, as projects progress, it's just kind of a learning. It's a learning curve. So we started out with maybe 5 or 6 people in the office that had some kind of BIM experience, and now I would say we're at least at 75% at this point.
And then another question, is the beautiful hand-drawn sepia sketch rendering done in Lumion or Revit? Also, is that a PPA proprietary render?
Are we talking about the house, I'm assuming?
The horse farmhouse, I believe.
Yeah.
Yeah.
That is Lumion. That's a Revit model in Lumion. It's not proprietary. It's just, the way Lumion works is you set up, you import your model, you set up your views, and then you take photos of those views, and then you start applying effects to it. And it's just a lot of trial and error in order to get to the point where we're happy with the effect that we have.
I'd say also when it comes to Lumion, we really opt for the monochromatic solutions. The color can get overwhelming. The amount of detail, it can quickly devolve into kitsch when you have birds flying over and the leaves are fluttering and they're butterflies, and there are people standing by the pool flipping hamburgers. It's not, in my view, some of these software programs offer options that you should avoid,
Do you have an in-house training program with these programs, or are you mostly hiring people who already have experience with these systems? How long did it take to build up these workflows in tandem with active projects?
It's kind of funny. It's a small office, so we don't have a full training regimen like a larger firm would have. So what we typically do is we have some online courses that give people the basics, so that I'm not having to train someone from scratch. That gives people a foundation, and then we put them into projects with team members that have some experience. This is the ideal situation, that the team is a mix of beginners and people with experience, so that the people with experience can bring the new people up. And it seems to work pretty well. And then, of course, I'm there in the background, ready to teach on specific items that need to be covered and controlled.
Yeah. I think one thing that's worth noting there is that the workflows that we employ are also kind of constantly evolving. So one of the tricks is just you have to try to stay current. I wrote a little guide for SketchUp modeling for 3D rendering purposes around when maybe 4 years ago. And at this point, almost none of it would be usable anymore because the way we've done the work has changed over time. So here's an important one. How does the different choice in tools, Revit or CAD, affect the final design? Is there common features in the project that you would use Revit for versus the ones that you would do in CAD? Are there any pros and cons for each software?
That's a big question.
Yeah, I think the ultimate, yeah, I think certainly the goal is that there would not be a difference in the outcome depending on which process we use. Yeah. These tools need to exist in service of the design work that we do. I think that's a really important.
But even more than that, I would say that there's a danger that they might affect the design, and I think this is a danger of Revit, that it can sort of trap you in a library of forms and be less fluid. It's certainly less fluid than your pencil, right? It's tied to physical things and specifications of actual concrete objects. So I think there's actually a danger that it could affect your design, and we really fight to avoid that.
Right. I mean, that goes back to the library question, is trying to keep things as generic as possible so that the teams can take those elements and breathe the life of the actual project into them. And they aren't made to be these static specific elements.
Here's one. Have you used Enscape at all?
I've experimented with Enscape. I preferred Lumion over it. It just Lumion is a lot more user-friendly. One of the reasons we use it, besides the fact that it does really rapid renderings and we can pump images out for client meetings like right at the last minute, is that it's easy to learn. So multiple team members can pick it up and run renderings with it without having to have a bottleneck with one person that's doing all the renders. So that's why we prefer, one of the reasons we prefer Lumion over something like Enscape.
There was a question about what program we use to do the stereoscopic presentations. And actually, the VR headsets that we use have a built-in image viewer software. And if you feed it the proper JPEG image, it will just automatically interpret it as a stereoscopic image. And you can just turn and look around in the space. So we don't need to install anything special. We just need to produce an image that's the right aspect ratio that the headset will be able to interpret properly. Here's a question. Will we use 3D programs like Revit to generate the CDs rather than AutoCAD?
Yeah, we absolutely do. That's one of the main reasons why we use Revit. I mean, otherwise there's no reason why you wouldn't just use SketchUp to create 3D stuff and continue on with the CAD for your construction documents. So the big advantage of using Revit is to be able to use it to create those construction documents and to be able to study things in 3D presentations and such.
Well, thank you all very much. I think it's we probably heard about as much as we can all absorb. As I said, I'm not an expert in this, and I love to see it being used effectively in the office, but it's complicated stuff, and we've really enjoyed presenting it. And again, I want to thank the ICAA and everyone for tuning in.